So welcome to lesson 1.4. We're going to talk about arithmetic sequences. Um, so the first question is simply, the first example here is simply, uh, is this sequence of numbers arithmetic? If so, what is the common difference? And then what is the next term? An arithmetic sequence is a sequence that, that has a common difference. So there's something consistently added or subtracted to get from one number to the next in the sequence. So if it goes 3, 8, 13, 18, 23, clearly this is arithmetic because the common difference is 5, right? So the fact that it has the common difference makes it arithmetic, and then the next term of the sequence would be 28, all right? Um, so it is a sequence. The domain is the natural numbers. Set it up as a table. Find the common difference like I was saying. Definition there. Arithmetic sequence is a sequence with a constant difference. And the common difference in this case is 5. And you end up with 28, right, for using in this example. All right, let's look at the next one. How could you write a formula for finding the next term in the sequence? So in this case, n represents the number of the term in the sequence. Okay, so f1 is 3 because that's the first number in the sequence. And then the common difference is 5. So f1 plus 5 is going to be equal to f2. And then whatever f2 is, you add 5 to that to get f3. So the formula would be any number in the sequence is whatever number it was before it plus 5. The general rule for an arithmetic sequence as a piecewise function is defined. So you have whatever the first term is, and then that's equal to specifically n equals 1, and then every term after that, you would have a function defined as f of n minus 1. This is considered the recursive definition, but basically it's just what you already know. It's just putting into function terms the fact that you're just adding 5 to the previous term. That's what that means. And you can use subscript instead of it like as function notation. It's a subscript, so then like the n still represents the number of the term. The first term is whatever it is, and then the second, every term after that is just adding the common difference to it. So that's just different notation to mean the same thing. All right, so is this sequence arithmetic? Well, 4, 7, 10, 13, 16. It is because it has a common difference. The first term is 4, and then the second term, well, every term after that is just the previous term plus 3. All right, so let's try it. All right, are the following sequences arithmetic? Well, again, you pause it, you try it, but then hit play and once you've tried it. Are the following sequences arithmetic? If so, what is the recursive definition? What is the next term of the sequence? So 25, 20, 15, 10. The common difference, and this is the first one we're looking at that's going down, but that just means the common difference is negative. All right, so this is arithmetic. The common difference is negative 5. The first term is 25. And then each term after that, you would add a negative 5 technically or subtract 5. So you could write it as a piecewise function like that. All right, so then again, a sub n is equal to 25 when it's the first term. Every other term is just whatever the previous term is minus 5. The next term in the sequence, which is subtract 5 from the last term there, is going to be 5. All right. The next one, 2, 4, 7. At that point, it's not arithmetic because it's a different difference between the terms. All right, so this one is not arithmetic. Okay. There's an extra example that you can try. So I want you to try that as well, and then I'll make another video for example 2.